Okay, these notes are over the unit circle. So it says the unit circle is the circle centered at the origin with a radius of 1 unit, hence the unit circle. Okay. The only important thing right there is that the radius is 1 unit. The equation of this circle is x squared plus y squared equals 1, and then a diagram is shown below. Okay. We're going to deal primarily with the special angles around the unit circle, namely the ones that have 30 degrees, 45 degrees, 60 degrees, and 90 degrees, since we know the patterns for each of these triangles, and that's where we learned the ratios for sine, cosine, and tangent. All angles throughout this unit will be drawn in standard position. Remember, standard position is where we start from the positive side of the x-axis. Okay. So first, we're going to look at the very first quadrant. And remember, if we have a coordinate plane, the first quadrant is this top portion here. So we're only looking at this top portion. And then here is the diagram of the circle that we have a zoomed in version of. So first what we're going to do is identify what these 2 points are on the graph. So this point up here and then this point down here. So what would be the point on the bottom? Remember, we're looking at a coordinate graph and we're looking at this point here. What point would that be? Unit circle only goes out to 1 unit each side. So this would be 1, 0. 1, 0. And that means on the y-axis, this is going to be 0, 1. Okay, because we're only looking at that very first quadrant. And what I'm going to do first is I'm going to label all the degrees, and then we're going to label the radians, and then finally the points. So if you remember, this top portion is 90 degrees. Okay. Then we have 60 degrees, 45 degrees, 30 degrees, and then 0 degrees. And each of these can be turned into radians by multiplying by what? Pi over 180, close, pi over 180. So if we do that for each of these degrees, we get pi halves, pi thirds, pi fourths, pi sixths, and then 0. Okay. And then for each of these angles, we're able to identify the point. And remember, a point is always x, y. So we're going to identify the points for each of these 60, 45, and 30 degree angle. And you'll notice as we're filling in the entire circle that these numbers are going to pop up a lot. So this is 1/2 square roots of 3 over 2. This is square root of 2 over 2, and then square root of 2 over 2. And this is the square root of 3 over 2, and then 1/2. Okay. So again, this is our unit circle for only the first quadrant. So I'll give you guys a minute to finish copying this down. And then if you go to the other side where you see the entire unit circle, you're just going to have to recopy that first quadrant. So if you're already done writing this, go ahead and copy it down on the entire unit circle, which would be on the next part of the notes. Everyone else, either take a picture or finish copying this down. I'll give you about a few seconds, then we're going to move on. So again, the important thing here are all these points that we found. So all these points that correlate with each of the angles. And remember, a point is always x, y. So what I'm going to do is I'm going to go on to the next section. It says, when it comes to the other quadrants, we will use the reference angles to determine the correct special right triangles used to find the corresponding x and y values. So if you recall, I'm going to first just fill in that first quadrant that we just did. And in that first quadrant, remember this was 0 degrees, 30, 45, 60, and 90. And then the corresponding radians is 0, pi 6, pi 4th, pi 3rds, and then pi halves. And then the x, y, yes?
So just the line between the pi and the number, it's not 16 pi.
No, it's I'm trying to do a fraction. Yeah, so it's pi divided by 6, pi divided by 4 fraction. Okay. And then plotting the points that go with each of the angles, we have 1, 0, square root of 3 divided by 2, 1 divided by 2, square root of 2 over 2, square root of 2 over 2, 1/2, square root of 3 over 2, and then 0, 1. Okay. Again, each of these points are going to correlate with the angle, okay? And when we're solving these ones, you'll notice the importance of this based on which quadrant it is. It's going to affect if it's positive or negative, just like if you were to graph a point on a coordinate plane. So right here at the top where it says positive, I'm going to write all. So that means sine, cosine, and tangent are all going to have positive values. And then on negative, I'm going to write none because sine, cosine, and tangent, like I said, are all positive, which means none of them are negative. And then we're going to continue finishing the circle. And we're on the second quadrant now. Okay, so starting with our degrees, if we ended with 90 degrees, that means our next one is 120. Then we have 135, 150, and then we know that half a circle is 180 degrees. Then I'm going to fill in the corresponding radians. So 2 pi over 3, 3 pi over 4, 5 pi over 6, and then pi. And then the corresponding points for each one. So that's negative 1/2, square root of 3 over 2. This is negative square root of 2 over 2, square root of 2 over 2. And this is negative square root of 3 over 2 and 1/2. And this is negative 1, 0. Okay, so you'll notice that those points in our x, y values are the same three numbers, just the positions are changing, and then sometimes the negative or positive pops up. So we're always seeing the 1/2, the square root of 2 over 2, and the square root of 3 over 2. Which means when we're using the unit circle to solve, those will be our three possible answers that we could get. Okay. And then up the top where it says positive and negative, the only one that's going to be positive is if you take the sign. And then the two that are going to be negative are cosine and tangent. Okay, so that's the first two quadrants. Now we're going to do quadrant 3. Remember, we ended at 180, so continuing with our degrees, we have 210, 225, 240, and 3/4 of our circle is 270. Then filling in the radians, starting from where we stopped at pi, we now have 7 pi 6, 5 pi 4ths, 4 pi 3rds, and then 3 pi over 2. And then our corresponding points, You'll notice this time that since we're in the third quadrant, both x and y are going to be negative. So we have negative square root of 3 over 2, negative 1/2, negative square root of 2 over 2, negative square root of 2 over 2, negative 1/2, and negative square root of 3 over 2. And then at the very bottom here, we have 0, negative 1. And then for the positive, negative, the only one that's going to end up being positive is tangent. And then negative is going to be sine or cosine. Lastly, we have the fourth quadrant, and we know that an entire circle is going to be how many degrees? 360. So we know we're going up to 360, but starting at 270, our next one is going to be 300. Then we have 315 degrees, 330 degrees, and then lastly 360 degrees. And then converting them all to radians, we have 5 pi thirds, 7 pi fourths, 11 pi 6, and then a full circle is 2 pi. And then filling in our fourth quadrant, you'll notice that the x values are positive, but the y values are negative. So we have 1/2 comma negative square root of 3 over 2, square root of 2 over 2 comma negative square root of 2 over 2, and then square root of 3 over 2 comma negative 1/2. And then of course they share that same value of 1 comma 0 with 0 degrees and 360 degrees. Okay. And then we're at the bottom where it says positive and negative. The only positive one is going to be cosine, and then the negative is going to be sine and tangent. And then on this unit circle, now that it's complete, I'm also going to just highlight this part here, okay? Because I want you guys to remember that this is the starting position or standard position. So this is the standard position, which means if we are going to graph a positive angle, we start from that positive, that standard. I wrote positive, not position. My bad. Okay. We're going to start right here, and then we're going to loop around for a positive angle. And remember, this is counterclockwise. And if we're given a negative angle, we start at the standard position, but do the opposite and go clockwise. Any questions on the unit circle? So this is something that I would eventually memorize, okay? You're going to be asked, depending on your teacher, to memorize this in geometry. Maybe 50-50 chance, right? But if you plan on taking pre-calculus, you will have to memorize this, okay? And the reason why it's important to memorize this is if we do some examples, so if you turn your notes over, okay, we're able to use the unit circle to get exact answers versus our calculators that are just giving us approximations because they're giving it to us in decimals, versus our exact answers here, which is going to be using the radical. And if you recall, we only have those 3 different values. We have 1/2 positive or negative, square root of 2 over 2 positive or negative, and then square root of 3 over 2 positive or negative. So this first part here is just saying how to use the unit circle to answer these type of problems. So this first part, this is not an example, this is just more of the notes, okay? So it's saying your unit circle, you're going to still use your trig function, so sine, cosine, and tangent, and then their inverses, cosecant, secant, and cotangent. And right here, you'll notice that the ratios look a little different, but if you notice and you reflect back to the triangle, it's still using the SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Here, notice that the hypotenuse is labeled as r. And r is equal to 1, and r stands for, any guesses? The radius. So the radius of a unit circle is 1 because it only goes to 1 unit on each side. So this is being used as our hypotenuse. And then you'll notice that they now use x and y because if we look at this like a graph, x right here is on the x-axis. So this is always going to be x because it's on the x-axis. And then this one here going up and down is y because our y-axis also is vertical, going up or down. Okay. So when we're solving these, we're going to be using these ratios. Okay. So in the example, so the first example here, it wants us to find sine of 120 degrees. So first we have to think, if we look back at our unit circle, which quadrant is it 120 degrees? 2. Okay, so I'm going to go here, and I know that 120 degrees is right here. And what I'm doing is I'm looking at my unit circle, and I'm following that same line that has the 120 degrees. Okay, and then I know that that means starting from the standard position going this way is my 120 degrees. Okay. Well, from that line, I'm going to draw a triangle. So I'm going to go down, okay, to the x-axis, and this is going to be my y, and then I'm going to connect it at the origin, and that's going to be my x. Okay. Well, if you go to your unit circle where it says 120 degrees, what is the coordinate point that they give us? Square roots of 3 over 2. Remember, this is our x and y values. So I'm going to take those values and plug them in on my triangle. So this is the square root of 3 over 2 because that's y. And this is negative 1/2 because that's x. Okay. Now I'm going to use the ratio that they give me at the top. And that ratio is that sine of theta is equal to, look at the very top, y over r. So y over r. So then I do sine of 120 degrees is equal to y. Y is the square root of 3 over 2 divided by r, which is always 1. That means my answer is just the square root of 3 over 2. Because my goal was to find sine of 120 degrees, and I just found it here by using my unit circle. Any questions on number 1? Okay, let's look at number 2. Number 2, it wants us to find tangent of 300 degrees. So looking at your unit circle, which quadrant is 300 degrees? The 4th quadrant. Good. So I am going to draw that line that's in the 4th quadrant, which is down here. And I know that starting from standard position, going all the way to that line is my 300 degrees. Okay. Then I'm going to use that angle to form my triangle. So I'm going to go down from the x-axis, and this is my y. And then go from the origin and connect that, and that is my x. Okay. If you look on your unit circle, what is the point for 300 degrees? Okay, it should be 1/2 comma negative square root of 3 over 2. Make sure you guys are able to find that on your own. Okay. And we know that this is x and y. So I'm going to fill in my triangle. I know this is 1/2 and this is negative square root of 3 over 2. And I need to find the tangent of theta, which is equal to what ratio? Look at the top of your notes. Y over x. So I'm going to plug in my value. So tangent of 300 degrees is equal to y, which is negative square root of 3 over 2, divided by x, which is 1/2. Remember, we're not using a calculator here. We have a fraction divided by another fraction, which means that's the same as taking the numerator and multiplying by the denominator's what? Anybody? Bring it back to middle school math. Negative square root of 3 over 2 times the reciprocal. So it's the numerator times the reciprocal of the denominator if we have two fractions being divided. So this is times 2 over 1, which means the 2's cancel out, and I am left with negative square root of 3 as my answer. Okay, any questions for example 2? Okay, so example 3 is going to be a little bit more challenging for 2 reasons. First, they give us in radians instead of degrees. So what do we have to do first? Convert to degrees. So I'm going to do that by multiplying 180 divided by pi. The pi's are going to cancel, so I'm looking at each of the diagonals. And then on the other diagonal, I can divide 4 and 180 by 4. And when I do that, I am left with 45. And then I just multiply across to get my answer. So I have 13 times 45, which is 585 degrees. Okay, and then notice it's over 1 because 1 times 1 gives us 1. What do we know about the degrees of an entire circle? It's how many? 360, which means that 585 is already forming one circle. So in order to find the degrees that are left over, I'm going to have to subtract 360 degrees. And when I do that, I'm left with how much? 225? 225 degrees. Is 225 degrees on our unit circle? Which quadrant? The third quadrant. So I'm going to go down to the third quadrant for my 225 degrees. And if I was to graph this, starting at the standard position, I would start here. I would complete my circle, then connect to my line. This is telling whoever's looking at this that this was more than 360 degrees because it already went around the entire coordinate plane once and then stopped in the third quadrant at 225 degrees. So this is a total of 585 degrees. Okay. I'm then going to take my line, connect it to my x-axis. This is y. And then connect it to the origin. This is x. So if I look at my unit circle, what is the points for 225 degrees?
Negative square root over 2, comma,
Negative square root of 2. Okay, negative square root of 2 over 2. And then negative square root of 2 over 2. So this is my x and y, which means I need to go to my diagram and fill that in. So both of them are the same. They're both negative square root of 2 over 2. And then in my original problem, it wants us to find cosine. So cosine of theta is equal to which ratio? X over r. So this is cosine of 585 degrees. That's what it's asking us to find originally. is equal to x, which is negative square root of 2 over 2, divided by r, and r is always 1, which means our answer here is the negative square root of 2 over 2.